continue what I have talked about in last week tutorials. So here is some examples and questions for you to try and see whether you can make sense of what I've been talking about in the last tutorial sessions. And these all are related to Gauss law. So the first one is a questions about finding charge enclosed in a cube. So these are very simple examples. So charge density is charge divided by the volume. And to find the charge enclosed, okay, so normally Q will be equals to the charge density times the volume. Okay, so this is a very simple example. Charge density has a unit of microcoulombs per meter cube. Volume has a unit of meter cube, and therefore we multiply the charge density with the volume that gives us the charge, which is in coulombs. Okay, so this just to illustrate these equations, the charge density multiplied by the volume give you the charge. So in this case here, charge density is 30 micron coulombs per meter cube, and the volume of the cube is said that is all sides is 1 meter. So our cube one meter, and then 1 meter. Okay, so to find the volume of this, we simply multiply x, y, and z. And this gives us 1 meter cube. Okay, so in this very simple example, I'm sure you have no problems working out the charge as long as you know the equations. The charge is equals to the charge density multiplied by the volume. And in this case here, finding the volume of the cube is quite straightforward. As long as you know the side of the cube, you can calculate its volume. And in this case here, all the sides are 1 meter, and therefore the volume of the cube is 1 meter cube. And therefore the charge will be equals to, not meters cube. The unit will be, what's the unit? Microcoulombs. Okay, so this unit of the charge. So you got 30 microcoulombs per meter cube times 1 meter cube. That gives you 30 microcoulombs. Okay, so this one is very straightforward. So we're going to up the level a little bit to what we talked about last week. Okay. So here, the same example, you have 30 microcoulombs, but it changed a little bit. The question asks you to determine the electric flux spreading through the volume defined by a limit. But the limit is 0 to 1 meter for x, 0 to 1 meter for y, and then 0 to 1 meter for z. So new information. So you want to find the electric flux. And from our lecture, we know that the electric flux is equals to the charge enclosed in that volume. And therefore, our electric flux equals to Q equals to the integral of the charge density times dV. Okay, remember we talked about last week in an X, Y, and Z coordinate system, we can define a very small volume and dx, dz, dy. And this will be our dv. Okay, in our Cartesian coordinate, my dv will be equals to, let me write it down here, my dv will be equals to dx, dy, dz. So instead of like what we did in the previous example, we simply multiply rho with the volume. Because we know the side, we can multiply it with the volume. Here, you're given the limits. So you have to integrate it over dv. And we know that dv equals to dx, dy, dz. Rho is 30. And then you can put in the limits of the integral. X equals to 0 to 1, y 0 to 1, z 0 to 1. 30 is a constant. We can take that out from the integral. And these integrations, because x, y, and z are orthogonal, means that they are 90-degree apart from each other. So you can separate the integration doing x, y, and z separately. So you can integrate the limits of x 0 to 1 for dx, y 0 to 1 dy, and then z 0 to 1 dz. Okay, integral of dx simply equals to x. So in the full integral, it will be x plus c. But here with a limit, we don't have to consider what c is. Okay, so you just integrate x within the limits of 0 and 1. And then integral of dy, that will be y with the limits of 0 and 1. And then z with the limits of 0 and 1. And then you can substitute in the limit. That will be 1 minus 0 for x, 1 minus 0 for y, 1 minus 0 for z. And that gives us the same answer as the first one, which is 30 microcoulombs. Because if I were to draw this limit, 1, 1, and 1, this also gives me a cube of 1 meter, 1 meter, and 1 meter. Okay, so it's exactly the same problem as the first example, but now we're solving it with limits of x, y, and z. Okay, so that is the first one. So I show you the first one. So what I want you to do is to try B. Okay, so now try and see whether you can work out what B is with a different limits of the integral. Anyone manage to solve this? What's Q equals to? Sorry? 240 microcoulombs. Everyone get the same thing? Okay. So from these limits, we know that one side is 1 meter. From this is 2 meter. And from here is 4 meter. So basically, all the top up to here is the same. And here will be 30. 1 minus 0. 1 minus 1. 10 minus 4. Sorry, 10 minus 6. Okay, you get this is equals to 30 times 1 times 2 times 4. And therefore you get 240 microcoulombs. Okay, so now you know how to use your Cartesian coordinates, x, y, and z, to integrate over a volume, dV. Anyone has problem with this? Okay, so the next one is on spherical coordinate system. Okay, here, so I did a simple example here. So again, the same charge density, rho equals to 30 microcoulombs per meter, 30 microcoulombs per meter cube. And now you're given the limit in the spherical coordinate system. It's going from 0 to 1 in the radial directions, 0 to 2 pi in the azimuth angle, and then 0 to pi in the elevations or the polar angle. So our Q, our charge, so here it's not asking for the electric flux, it's just asking for the charge. Actually, they're the same thing. Okay, so the charge enclosed in this volume will be into the integral rho dV, and dV in this case here is equals to r squared sine theta dr d phi d theta. And this is come from the explanation that I tried to show to you last week from spherical coordinate systems. The dV is equals to r squared sine theta dr d phi d theta. And then we have our limits for the r equals to 0 to 1. And then for phi is 0 to 2 pi. And then theta is 0 to pi. Again, your r, phi, and theta, they are all orthogonal, which means that they are 90 degrees apart as well. Okay, in our coordinate systems, we have our x, y, z, and then we have our r, and then this is our phi, and then from the top, the theta, or you can think of this going in this direction, theta. Okay, again, they are all orthogonal. They are all 90 degrees from each other. Again, you can do the integral separately. So you can integrate with respect to dr separately, with respect to d phi and d theta, all separately. Okay, so we got r squared. So 30 again is a constant, so we can take 30 out of our integral. R squared dr, we get r cubed over 3. And then the limits is 0 to 1. d phi. Okay, so we don't have phi in this equation. So d phi integrated will be just phi. And then the limit is 0 to 2 pi. And then the integral of sine theta, that will be minus cosine theta. And then that will be with the limits of 0 to pi. Put in the limits, 1 into r cubed. So 1 cubed is 1 over 3 minus r is 0. So 1 over 3 minus 0. Pi, limits 2 pi, 0. So it's 2 pi minus 0, give us 2 pi. And then cosine theta, so minus cosine of pi, that will be minus, cosine of pi is minus 1. So minus 1 times 1 give us 1. Okay, so here is minus 1, minus, and then minus cosine 0, that will be 1. Okay, so this is 1 plus 2, no, plus 1, and give us 2. Okay, your cosine functions, cosine 0 give us 1, cosine pi give us minus 1. And therefore 30, and 3, this gives us 10, times 2 times 2, that's 40 pi microcoulombs. Okay, so that's the example. So again, I want you to solve the second one with a different limits. See whether you can solve this. So the first one, actually, it is just a sphere with a radius of 1 meter. R squared, yes. First Q. Anyone solve it? So it should get about 74 pi microcoulombs. Or if you multiply the pi, it will be 232.3 microcoulombs. Everyone got that? Okay. So things to remember. This is my dV for spherical coordinate systems. So I'll ask you, what is the electric flux enclosed in this volume? What would that be? So first one, what's the electric flux enclosed in this volume defined? Yes, 40 pi microcoulombs is the same thing. Yeah. So the electric flux enclosed is equals to the charge enclosed. Similarly, for the second one, the electric flux enclosed in this limits of volume is also equals to the charge enclosed inside this volume. Okay, can I move on? Okay. So third one is on spherical coordinate system. So no, this is on cylindrical coordinate system. So now we have our radial r, and then we have our azimuth phi, but instead of a polar angle, the z remains the z direction, so that you can get a cylinder. So what is dV in this case? So here is dz. Here is dr. And what will be this distance? We have r d phi. So this distance here is r d phi. So remember I mentioned in last week that this distance here is equals to the side multiplied by that angle. So therefore my dV, this volume here, dV, will be equals to r dr d phi dz. And this is for a cylindrical coordinate system. Okay, so with that information, I'm sure you can solve 1 and 2. You can go ahead and try that. Okay, so that's the first one. You should get 150 pi. Everyone get that? Okay, so the part where I put a black bracket there, that's basically calculating the volume of a cylinder. So in this case, the volume of the cylinder of a 1 meter in radius with a height of 5 meters. And then the second one is not quite a cylinder, but a cylinder with certain part of it cut away. Okay, so means that you have a cylinder that's going from something like this. Okay, with part of it cut away, and then the center of the cylinder being cut away as well. But with the integration, you can easily solve that by just putting the right limits to the integrations. Anyone solve that? What's the Q for this? So the second one, you should get about 118 pi microcoulombs. Don't get that? Okay. Okay, so here is another example. So now, instead of a constant rho, constant charge density, now the charge density changes with the directions. For x, changes with x and y directions. So your integration now is not simply integrate over dx, dy, dz. You have to take into account of the changes of the charge density with respect to x and y. So the limits is given in x, y, and z. So this is in Cartesian's coordinate system. So the first one, Q. Rho dV. And that will be 30 x squared y dx dy dz. 30 is constant. X is from 0 to 1. X squared dx. Y 0 to 1. Y dy. And then z 0 to 1 dz. X squared, that will be x cubed over 3. 0 to 1. Y squared over 2. 0 to 1. And then z 0 to 1. 30, 1 over 3, 1 over 2, 1. So this gives us 5 microcoulombs. All right. Okay, so that's all we have time for today. There are a few more questions. I will put it on Moodle. You can try those questions as well. Yes. What do you mean? What's the question? B. Yeah. So is it the same? The limits is different, but you probably end up with the same answer because it's y squared. Actually, it's no, it's not the same. It's the negative 5.